Good morning, students. Today you can see what is our topic before we start. So, what we are going to do before we start? I thought before we start for the chapters, I should teach you about the main tool which you will use in your next and some of the chapters, and it will be useful for your whole study. Though the thing is they are in your mathematics, but still, as a physics teacher, I will teach you in a manner of physics. That means you will know what and how we are going to use it and what is the use of it, actually, the purpose of it. Okay, so what is that chapter? What is that chapter? Let me think. Okay, so the topic is differentiation. Many of you uh, have heard of this, okay, differentiation, but I don't know how many of you know about it. So, differentiation is kind of operation, and it's just like your addition, subtraction, division, and multiplication, but it has some definite features also. What kind of definite features? It slices functions. What does it mean? Hmm. So before we start for this, what is a function we should know at least. Okay, what is a function? Let me say you. The function means, let's say y is a variable and it depends on another variable x. So both are variable. My y is also a variable and x is also a variable. Fine. But y depends on x. So as I choose x values, y will be automatically manipulated according to that. That means y is a function of x. So what is a function? Function is a composite form of variables. Like here the composite form is 2x plus 1. So who is dependent variable? Here y is my dependent variable, whereas x is my independent variable. Okay. Now, so we know what is a function right now. Let me tell you a story. Okay, not story but a situation. Let's say I have a big circular ring. My God, it's not a ring at all. Let me try to draw a nice one. Okay, let me take a circle. Still it's not happening. Okay, I'll draw from here. It's quite big circle, man. Okay, let me take the circle here. Okay, so in this circle, there is a small ant. I am a very small ant. Please respect me. So the ant is moving. Sorry. Now, as the ant is very small, what it is seeing right now? It is seeing a very small portion of the circle. So, if you are there with that ant, you will see a straight line going like in front of you. The same scenario we can see here where we stay in earth. So this is our earth. So when one man is standing here, he sees everything as a flat surface. What? As a flat surface. Now, you know that the earth is a sphere, a round sphere, but he is seeing a flat surface. Why it is so? Here, the same scenario, the ant is seeing a straight line. ant is seeing a straight line. Okay, the stylus is making problem, and even I'm not. Um, okay, so he's seeing a straight line, though we know it is a circle. So the form itself is changing when we see a small portion of it, right? So we need something to know कि if we slice one big function, how it will look like. Here comes our great scientist Newton. Newton was there in Earth. We know he's not an alien. So when he was in Earth, he wanted to test his theory of gravitation, right? We know that. So what he used to do, he actually made one telescope, and he used to see the motion of that comet in some interval of time. Okay, but he can see only a portion of its path. So he cannot, like he was not able to understand the whole path itself. So what he has done, he has thought कि I need some mathematical tool which will help me to convert small portion of any function to a big portion. Like this is a small portion, okay? But when this all small portion will add up all together like this, 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 this. So ultimately I will get a big function, right? So this thing was very questionable among his mind. So what he has done, he has made something which we called as differentiation and integration. So differentiation and integration. Now, what are these things? This is to make the functions bigger function, to make the bigger function with help of small functions, okay, with small functions, fine. And this is to cut the big function into small functions, okay. So these two things are used. Now see how we have taken this. Let us say how it will help us in our further study. So we will think like that. So let us say we have a graph, okay? We have a graph and we have a curve like this. The graph is all about your distance versus time. So let's say one car is there, okay? It's a very bad car. I don't know how it will not be sold if I make this, but still, okay. So the car was running with some velocity, fine, but it is covering the distance in some time, okay. So somebody has recorded the distance and time, and then he has plotted the whole curve like this. We know that if we know that the velocity is distance by time, right? But here you can see if we have drawn this portion, let's say this point I have taken. So in this point, this is my x, this is my t. So my x is bigger, t is smaller. Here, if I take this point, so this is my delta x. Sorry, here I have taken the wrong. So this will be my delta x, and this will be my delta t. So in this case, this is my delta x and this is my delta t. You can see clearly here delta x is very smaller compared to delta t, but here almost it is same. So this ratio, anybody can say this, this ratio is not same for this point and for this point. So the velocity here is different than the velocity here, right? Okay. Now for the same that graph, for that same graph, now if I choose any instantaneous point, any arbitrary point here, say I want to find the velocity here. So what I can do, as this is a curve, I can draw a tangent here, right? Let me draw nicely, okay, with some different color. So I can draw tangent like this, and I can take a triangle like this. So if this is my x-axis, this is my t-axis, so this will be my delta t. That means my, what is my, this is say t1, this is t2, so delta t is nothing but t2 minus t1, and this will be my x2, final distance, minus initial distance x1. So this will be my delta x. So my delta x is x2 minus x1. Fine. Now we can see that v is, we know that delta x by delta t. But one more thing is there. What is that one more thing? See, we know also that if, say, this is the angle, then we know that tan theta, what is tan theta? We know it's trigonometry, perpendicular by base. So my tan theta will be the perpendicular, that is my delta x, and the base, that is my delta t. So I can see that this v is nothing but the tan theta itself, right? But one more thing you have noticed. So, the first thing is that with this theta, I can assume, or I can put a, what do you say? I can guess what will be my velocity, because there is a correlation, because velocity is also delta x by delta t, and tan theta is also my delta x by delta t, right? So there is a correlation between these two things. So I can say always my tan theta is equal to v equal to delta x by delta t. Now you will say, why? What are the things you are doing, sir? Now see. Now we come to again our differentiation. One thing you can see clearly, that as this is a curve, and if we choose a triangle like this, okay, so to find the velocity here, but you can see this triangle, the hypotenuse of this triangle is not following this curve, right? So the curve is bended like this, where the triangular hypotenuse is in another direction. So there is some deviation, right? There is some deviation in the both sides. So that means we are not accurate. We are not measuring it accurately, right? How to make it accurately? You can see the more we go smaller and smaller. The smaller triangle I'll make, okay, the accurate will be the data, because the smaller will be the triangle, this deviation, what we can see here, this deviation will be lesser and lesser and lesser, right? Because if we have a smaller triangle, this deviation will be lesser here, right? But deviation is higher for a bigger triangle. So how to make the triangle small? We know that this is our x, this is our t. So this is our delta x, this is our delta t. Now I can say that either I will make delta x very small or I will make delta t very small. But the problem is that delta x is the distance covered and a car is going with his own mind. So I cannot control how much distance it will go, but I can control delta t. That means in which time of instant I want to measure the velocity. Let me give you one example. Give you an example. Like the car was going in 5 minutes. The car was moving from 50 meter to 75 meter. It's very small, still like for a case only. So see, this whole distance, it has gone with variable velocities. So if I take 50 to 75 meter, okay, in 5 minutes, so there the velocity will be varying a lot. So I cannot measure the accurate velocity at that instant. But if I say that the car has gone in 5 seconds to 50 meter to 50.5 meter, so see here, in this small time period, the velocity has varied less, right? So that's why I can do it in two ways. First way is that I can make delta S small. The next way is that I can make delta t small. So the velocity, we know that delta x by, sorry. So the velocity is our delta x by delta t, right? What we are going to do, but this is our approximately, because we are not getting a precise value. So I am putting a limit. Okay, I want to make delta t nearly 0. So I am making this delta t small. So delta t will be small, so I will get a smaller triangle, right? So delta x by delta t. So I am making this delta t very small, okay? This thing is called, this whole thing, when I will make a small triangle, then it is called differentiation. That is dx by dt. That means I am slicing the function of x with respect to the time parameter. That means I am making the time smaller to see how much delta x is covered. And this rate, this whole thing is called my velocity, the rate. The change of delta, the change of x, the distance, with a very small time interval, which is near to almost 0, will be called as my velocity. This thing, d by dt, you cannot cut d and d. This d by dt is called differentiator. Okay, so you cannot cut d and d. Okay, this whole thing is a one thing. This means it can cut functions with respect to t. Okay, so with t it can cut function. Now coming for the application, how to apply. Okay, See, in mathematics you will learn how to get that thing, okay, but I'm not going into details. I have just told you the practical use of it, how it is like how we can use it in our physical systems, okay, for motions and many things, okay. And like I'm just giving you one formula, like say you have x to the power n, y equal to x to the power n. So y is a function of x, okay. So y is a function of x here, okay. From this we can get, because y depends on x, y depends on the values of x. So if we want to cut y with respect to x, so I can put dy dx, which is nothing but d dx of x to the power n. Now there is a formula for that. This n will come in front, x will be as usual, and this will be n minus 1. So this is a formula. Don't ask me how it has come, because it's a matter of math and you will study in your math, okay. This is there in your syllabus, so anyway you are going to learn it, so I'm not going into that details. You just learn it. Okay, this is the formula for dy dx, okay. Like in that case, let's say our case, okay, we have I'm going into one example here. Let's say any car is going like this, 2t square, okay, like this, 2t square. So I know that, like I can find out, okay, like if I have a plot x and t, I can find out that initially it will be 0, so x will be 0. When time will be 1, then x will be 2. When time will be 2, so it will be 2 square means 4 to the 8, okay. So x will be 8, like that it will vary. But I want to find what will be v. Fine, okay. So like let me create a new page, okay. Now see, so we know that here for this case x equal to 2t square, so x equal to 2t square. I also know that v equal to dx dt for instantaneous time, when this only can be done when x is not constant and the thing is moving. So x is changing with t, and that's why we can use this formula, okay. Now see, if so my v will be d dt of x, so it is d dt of 2t square, okay. 2 is a constant, it can come out because it is not varying. So ultimately 2 into d dt of t square. Now using this formula nx to the power n minus 1, if you use this formula, we will easily get 2 will come in front t, then 2 minus 1, so ultimately we will get 1, so we will get it 4t. So we can also see here my v, interesting thing, my v is also dependent on t. My god, that means if we take the what you say values, so at 0 t will be 0, t equal to 1 this will be 4, t equal to 2 this will be 8. So my velocity is also increasing in this case, right? So this is how we can use differentiation in our physics, okay. This differentiation, the physical significance of it was very important, that's why I thought to tell you first this thing, right? Now coming to the very first thing, that is our ant, okay. Now see, one very interesting thing I'll show you today. Ant was seeing the circle as straight line, and we can see from outside the bigger function, that is our circle, right? Now circle, we know the equation of a circle is x square plus y square equal to a square. What is a? A is the radius. And what is x and y? Coordinate of any point, right? But the ant is seeing the very small portion of the bigger function. So if we want to find out what ant is seeing, then we have to slice the function, right? So I am going to slice this function to see how the smaller portion looks like. So for slicing, what is my operation I have to do? I have to do differentiation, that is either ddx or ddy, because both are here independent variables. Okay, they both can be taken as independent. So let me do ddx. So if I do here ddx, so let me do ddx of x square plus y square equal to ddx of a square. Okay, so we can split it. Okay, so this will be ddx of x square plus ddx of y square equal to, now see, one thing I must tell you. Okay, I'm just removing a little part here so that I can tell you this thing. Okay, now ddx, I told you already, ddx is nothing but your tan theta, right? Dy dx is your tan theta. That means the slope, the angle in a graph. If say something is constant, so when we draw something constant in a graph, we draw like this, right? Let's say y, this is x. But say I want to draw a constant, that is y equal to 5. It's a constant, right? What is the angle of this constant with the horizontal line? If we tell about the angle, we will see angle is 0 actually, right? So the angle is 0. We know that tan theta is 0 when theta is 0, right? So dy dx is also 0 for any constant. So here a is the radius, and the value of a will not change anyway. So this is a constant. So whenever we do differentiation of a constant, we will get a 0. Okay, fine. ddx of x square. Okay, now using that formula which we have done at the last, this formula. Okay, so if we talk about this formula, so and if we just apply this formula here, so we will get 2x plus 2y. Now see, this is another function, so I will get one more thing, that is dy dx. This you will learn in mathematics. Okay, I am just showing you the consequence and how differentiation can be realized in real life. Equal to 0. So I can take 2 common and make it 0. So I'll get x plus y into, this is nothing but your what you say, angle dy dx. You know, dy dx is tan theta. So slope, I can write this as some alphabet, let's say m. Okay, so m equal to 0. Voila, see this one here. Okay, this equation where we have started, this was the equation of a circle. Okay, so this was a equation of circle. But what at last, after slicing the function, we are getting this one. This one is a equation of straight line. Straight line, right? Like see, y equal to mx plus c, or x equal to my plus c, here c equal to 0. So we can see one thing very nicely, that using this differentiation operation, we can slice any function and we can see how it will look like. And it is very much matching with our reality. Whenever we are there in Earth surface, we know that Earth is sphere, but in front of us we can see that the earth is very flat. So the function of a sphere we cannot see. We can see only the function of a plane, right? So this is how a perception can be changed. Whatever we are seeing in our real world may not be true at all. It may be that we are seeing a very small portion of it or a very small part of it. Okay, so I want to make a summary of the whole thing, why I was telling you this whole story, because I wanted to tell you about differentiation, right? So you have seen that what is a function itself. Then we have seen the story of a ant and the realization why we see our earth as a flat surface, because we see only a small portion of that function. Then it comes why differentiation and how it was discovered. It was discovered by Newton while testing his gravitational laws. Okay. Then differentiation and integration. Now, what is integration? I'm just telling you small, very little bit about it. It will also be helpful in our study. Integration means joining the small function. So Newton was doing this thing only. Newton was able to see only a portion of a function. So using integration, he has created a bigger orbit of that comet which he was seeing. Okay. So by doing it, he can calculate the orbital period, he can calculate the orbital radius and epicenters and all those things. Okay, and he can verify his theory with the observational data. So after that, we have seen how velocity is dependent with our differentiation, right? Then we have seen how like differentiation has come by putting a variable to its very small value. Then we have seen that we cannot cut dd because ddt itself is a whole one thing and it acts as an operator. We have seen a very general formula for it. Okay, and this is it. So I'll just do one more thing. I'll just make a small note for you, that is for today's study, ddx of any function we have learned comes like this, right? ddx of any constant is 0 because the angle itself is 0, right? Okay, acha, ddx of two function of x, say one is fx and another one is gx. Two function, let's say fx is 2x plus 1, gx is say x cube. So in both case we can write it separately and do the differentiation separately. Okay, no problem in that. So this little note you keep it in mind. Okay, so for today this was the topic about differentiation, because I wanted to let you know this thing. Okay, there are many problems regarding my classes because I am not very much comfortable with this kind of teaching procedure, and I cannot talk with myself like this. It seems like that I am not talking with you, I am talking with myself, and that's why there are so many problems I am facing now. Thank you guys for your support, and please read about a little bit. I will upload some notes, okay, later on, and I will upload one worksheet. Your unit that chapter is there, unit and measurement. I will teach you from error uncertainty part. Okay, before that I will recommend you guys to read, and if you don't understand anything, please let me know, then I will try to make you understand that specific topic, right? Okay, see you, sayonara.